All right, everyone. All right. That's fine. Please give Kevin McCartney a warm welcome.
Hey guys, how's it going? Today we are going to be building a user interface the way that Facebook does it, and or React from first concepts. So, hey, thanks for coming. As Chris said, my name is Kevin McCartney. Here are a few of the things that I do. I am a consultant here at Cardinal Solutions. I am an application developer at Point. And I help co-organize the Creative Conception Meetup, which has yet to come up with a logo yet. So how did I get here? I am an art school dropout. So I was in school in Athens at OU, and then I decided to move to California on the advice of one of my trusted advisors. There also might have been a girl out there. And while I was there, I was continuing to go to school for graphic design, but I had to take a sales job to kind of make ends meet. And that's when I found out that I am an incredibly bad salesperson. So, aforementioned girl convinced me to join the development team at the company I was doing sales for. But I was, not going to be able to do that without a little bit of work. But I thought, hey, what the heck, let's go for it. So I hit the books, I started building stuff, and after some intense studying and some time invested, got a position on the development team there at that company, and I loved it. So one thing that I've learned throughout my journey over the past couple years in doing web development is the power of free learning and community is pretty awesome. And I just really love the sort of opportunities that we get as people who create digital products. I think that we have this incredible, not only responsibility, but like privilege to be able to affect the world around us. Whether that's peace, justice, equality, whatever you want to call it, or just making somebody's day not suck. So I want to let you guys know what you can expect to get out of this workshop. So we're going to go over a high-level explanation of how HTML, CSS, and JavaScript provide web apps for the browser to render. You're going to have some familiarity with the core concepts and fundamentals of React. And we are going to have a functional UI built in React that you built. Now, as I said, we were having some technical difficulties, so I'm going to go ahead and run through the examples here. And I will have the public API up probably later today, so if you guys want to go and follow along later, I have this entire talk posted as a collection on CodePen, so you guys can kind of follow along with that. But let's get going. It's going to be a wild ride. We've got a lot to cover, so we're going to get started. So on a high level, what we're doing today is building a functional UI component with React. So there's a couple of questions I think are kind of instructive when we think about why we're doing something. So why user interfaces? Well, first of all, great UIs are crucial to successful products. You're not going to be able to create value for a user without them being able to use your product easily in a way that speaks to them. It's a really big challenge. We all come from different backgrounds and perspectives, levels of technical literacy, and sometimes you're just tired and not thinking straight, and you need to take into consideration all of those different pieces of state when you're designing an application for a user. And it's in demand. I mean, UI and UX are a very rapidly developing field. A lot of cool and exciting things happening there. So definitely a good time to get in on something like that. And then why React? So one of my favorite things about React is that it has an incredibly vibrant and active community around it. You can look at that as it kind of being the new kid on the block. It's the new hotness. But I really do think that the people who work with this tool and maintain it and help it build and grow really care about making the best product that we can build stuff with. It has some really good core concepts. So when I talk about the core concepts behind React, it's stuff like functional programming, unidirectional data flow, component-based architecture, all these really big wins that help your application to be more deterministic, so like understandable in what it's doing. It's generally easier to read the code when you're going through like a React application because you know exactly what's happening every step of the way, which is very clear, concise, and performant. It has really great developer tooling around it, some of the best, in my opinion, that I've had the privilege to work with. A lot of really cool inspectors and debuggers that you can use. You can do native application development with React Native for both iOS and Android. React is actually really good for SEO, which is a big consideration when you're doing like front-end JavaScript frameworks. You can actually render your React server side so that it's already there for the search bots to crawl. And React is really fast. The React DOM implementation was one of the like really pivotal things that kind of came out of JavaScript in a while. It's been adopted by a lot of other frameworks and really good concepts behind that. So since we're going from first concepts, I really want to just start at a base level here. So like, what is a website or a web app? So a web app is an application that runs in your browser. How does that happen? So I'm about to kind of throw some technical terms at you here, but just stick with me because we're going to break these down into really understandable chunks. So basically how this works is the browser reads the combined DOM and CSSOM generated by the HTML and CSS respectively. So it's a lot of big words, but again, we're going to kind of go into what that means in very simple terms. The browser also provides a runtime for JavaScript to execute. We're going to get into that a little bit later too. But let's start with HTML. So HTML, hypertext markup language, it's the building blocks of web pages. So HTML defines the structure and the semantics of your page or your app. HTML entities are delimited by an opening and closing tag with angle brackets and a slash. I'll show you what that means. So right here, you have each of these little entities between the brackets are tags. And you can see that the beginning tag is just 2 brackets. The second one has a slash to indicate that the tag is closed. Anything in between there can be either content or properties of that HTML tag. So where this gets really cool is the DOM. So the document object model is an object that represents HTML tags as nodes in a tree based on the structure of the HTML document. Again, that might be a little bit kind of esoteric for now, but let's take a look at something that might help explain that a little bit better. So when you're looking at the DOM, or the document object model, basically what we're saying is that when you go to a page, when you hit google.com, you're getting a document. It's going to return you one root element that can have a bunch of different children. So it could have a head element that could have a title, which would tell the browser like what to display in that top bar. So when you go to google.com, the title would be Google, and that would display in your top browser bar. You can have headings, you can have links, you can have all kinds of different entities within this object model. So if we were looking at this like in a traditional object standpoint, you might have the kind of the root of the tree being the document, the HTML, the head, the title. So everything's nested together and they can have different properties. So if we look back here, you can see that the title element had a text property of my title, or the A element had an attribute of an href. So you can see that these properties exist within these objects. Properties and are just attributes of those objects there in between the curly braces, and then the values are just the value on the other side there. So text is the attribute, and linked text would be the value. So then CSS is cascading style sheets. And what CSS does is it defines the visual styles and layouts. And CSS rules are essentially objects with declarations and values. So they're going to look really similar to what we just looked at. So here's an example here. So you might have something like body, font size 16, body span color red. And this might not make a lot of sense right now, but it also gets parsed into this object similar to the DOM called the CSSOM. The CSS object model is an object similar to the DOM that has CSS rules as nodes in a tree based on the structure of the CSS style sheet. So if we look here, we can see that we have these different rules here. Every selector, which is the text in front of the curly brackets, is the beginning of like a rule, and then everything within the curly brackets would just be the rules that are being applied. And I think it gets a lot easier when you look at a picture like this. So you can see that the body has, again, like these key value, font size 16, and then they inherit from each other. So when you're going from the body to a paragraph, it would still have that value of font size 16, but it's inheriting it from something up higher on the tree. And then our final piece here is JavaScript. So JavaScript is a high-level, dynamic, untyped, multi-paradigm, and interpreted programming language. That probably doesn't mean a lot, but really, when you break it down super simply, a programming language is simply a set of instructions for a computer. And then JavaScript runs in a VM, or a virtual machine, which is basically like your computer, but it might not have like a desktop or whatever. It's just a machine that can understand instructions, and it's either in your web browser or it can be run on a server. For our purposes today, we're talking about JavaScript that would be run in the browser. So JavaScript can use logic to mutate the DOM and the CSS object model, as well as perform other functions such as network requests. So let's take a little bit of time, since we've kind of gotten a really high-level overview of how the DOM and the CSSOM work, to talk about the fundamentals of React. So what is React? React is a declarative, efficient, and flexible JavaScript library for building user interfaces. Again, that might not mean a lot, but what that really means is that React is a tool for rendering and managing the state of your user interface. So let's take a look at some of the core concepts of React. One of the really big things that you'll hear about React is that it's unidirectional data flow. So similar to how CSS might inherit from a tree item that's higher up in the tree, in the same way, data in React flows from one root element, and then it just goes down through all the other elements. It's also component-based, and with those components, you can have two different kinds of components. You can have container components and presentational components. And I'm going to be giving you examples of all of these when we go through some of the practical examples here. But basically, the difference is that container components hold data, and presentational components only render something based on the data that's passed down into them. The components have a life cycle, so when their state is getting updated or when they're being rendered, React knows about this and can kind of hook into that and say, okay, when this object is rendered, then also do this. And something that I'd mentioned before was props and state. So the idea with props and state in React is that everything that is a prop is passed down into an object, and state can be internal. And I think this will make a lot more sense once we kind of start to look at some of the code here. Then JSX is simply it's a way of expressing JavaScript that will render HTML more simply and in a more concise fashion. So it's time to code. As I said, I was having some issues deploying the API to one of my servers, so I'm kind of going to have to see how this works here. I had it working about an hour ago, and for some reason it just quit on me. So I'm going to grab the window here. So here is our base React app. Let me see if I can pull this. It is full screen. OK. So you can see some of the stuff that we were talking about earlier. you can see that there is an HTML entity here. So it's just a div, which is just a container. And it has this attribute called an ID. And the ID's value is the React root. Now, when I said that JavaScript can change the DOM, it can mutate it. So what it's doing here is there's a JavaScript function that is telling, it's rendering a component into this DOM element right here, so the React root. It's getting that element by its ID here, which is like the value, key value. And then it's telling it, when you find that element, I want to render this component in here. And this is the component that we're rendering right here. So this is just the definition of a React component. It's using some ES6 syntax, which is some brand new syntax defining a class. Basically what this is just a way to hold state, and you can do functions with them. So what you really need to know is the React components can render elements into the DOM here. So what we're doing is we're calling a constructor, which is like when a new instance of this component gets called, then it's just initializing it with any props, which is kind of data that's passed down into it. But what we're really kind of interested in here is the render method. So this right here is a function that is just returning all of this HTML here that you're seeing being rendered on the screen. So you can see that there is like a title element here that says my social network, and a card that holds the text hello world in there.
Hey Kevin, two things. Can you make your font a little bit bigger?
Yeah, sure.
And can I adjust your mic really quick?
Yeah, definitely.
Sorry.
Yeah, no worries.
Can you keep turning your head?
Yeah.
Is that JavaScript? Is that a JSX file right there?
So this is a little bit different than how it would be run like on your local computer. This is CodePen, which is just providing, this is not something that would normally run in a browser. Most browsers aren't set up to interpret something like this. So what you have to do when you have code like this that can't be interpreted by a browser is you do something called transpiling, which basically all you do is you run it through a program that turns it into something that the browser can't understand. So this is the first step here. We've defined our component, and then we're just rendering it into the DOM. So let's go ahead and pull up our second step here. So I am going to...
Can you bump it up one more notch?
Yeah, definitely. Let's see. So then this here is going to be the second step. So now, what we're doing here in this step, the main thing to be looking for is that instead of rendering this little card here, this hello world, we're now calling another component here. So this FeedItem is defined down here in much the same way that we defined our application component. So what this is doing is this is just returning this hello world text with render FeedItem, and that's getting called here in the render function of this class, which is what's always going to return your HTML. And there is a reason that we are basically separating these out into two different functions. And that'll kind of be explained here in the third step. So let me pull that up. And so this is the part where it broke about an hour ago, and I've not figured out how to fix it yet. So this is my dry run, so I catch things like this early. And I have a couple days to work on this, but I still want to run through kind of what this code is doing here in the third step. So what I'm doing here in this third step, the big thing we're doing is we're making an API call. And that's really just a fancy word for I'm reaching out to a server for some information, and then we can do stuff with that information, right? So what I'm doing now, I want you to take special notice. So I'm setting my state in the constructor. So this app now has a piece of data to it called its component state, and I'm telling it that the API data is null when this component is first initialized. And then this is going into what I was talking about earlier with React's lifecycle components. So this is saying if the component did mount, then I want to start calling the API. So I'm assigning the value of the call API function, which is right below this, to this API response variable. And this is kind of a special JavaScript, it's a keyword here, this async keyword is basically allowing us to use this right here, this await keyword, which is telling us that this call is going to be a network request. So we don't know how long that's going to take. So we want to wait for it until it's done. Then we set the response to the API data. And then in this step, if this was loading in the data from the server correctly, it would be taking that response, turning it into just a string of text. This is the API call function here. Again, it's just querying a URL. And then once it gets a response, it's returning that response. If there's an error for some reason getting it, then it's going to tell us about the error. And then down here, we are, as with every other component, we're rendering into the browser here. So we're telling it that we want to get the API data from the state, and then we are going to render our application. And now we're passing in, this right here is a prop. So this is a piece of data that's being passed down into the FeedItem component. And the FeedItem component can't change that. It can only read it. And then when we come down and look at the FeedItem here, I added another piece of state to this constructor. So this is telling me that when this component is initialized, the state of that will be that it does not have any data right now. And we're using another lifecycle hook here to say when the component does receive a new prop, then I want to update the data to be that API data. And the reason that I have to do this is because, as we said here, when we're calling this API, it's not going to be immediate. We have to take some time, but then the parent component notifies the child component, because once this API response gets set in the state, then when we're rendering it down here, this API data from the state would be a different value. So that value is updated, and the FeedItem is notified, hey, I have new data. I need to run my rendering again. So then once we have the data, I've just been rendering that into the row. And if the data is present, then we render this FeedItem. And that's just returning the data for right now. So if this network request was going through, what you guys would be seeing is just another object, like we've seen in previous things we've been looking at here, that would just represent some data from the server that we want to use in our application. And so then what I'm doing here, I still have all the API calls. Still rendering that feed item with the data from the API. The only thing I've changed here is that these are all data points on that response. So like an avatar, a full name, and a username would all be a piece of the user response from the API, and the message would be another part of that response. And once we have that, then we want to load everything in. So right here would be where we'd be loading in like the avatar. This would be loading in the full name with the username right here, and then whatever message that we put in. And then it's just rendering that data. If the data is present, then we render that feed item with all the data laid out correctly. If not, then we just render a piece that says that it's loading. And this is what it's supposed to look like if you don't have to call an API. So what it was doing here, oh, that's so weird. I wonder why that's working. So let me run through the entire thing here with you. So basically, like I said, this is the API call. This is the data here. The real new part here, and we've kind of already gone over like what all is getting rendered in. Like I said, like the avatar is getting loaded in here. We've got the full name, the username, and then the message. So what I did with this step, the final step here is just to allow you to click this button and record a like. And then if you decide you don't like it anymore, then you just click it again, and then there are no likes. How we're doing that is there is a component down here called like button, and we just made a brand new component here at the bottom. We're initializing it with some state that says when it's first rendered in, it should not be liked, and it doesn't have any likes. And then this toggle like is going to be a function that's going to get called once we click on here. So it's just saying once we click on here, do something. So it's looking at the state and saying if the state has said that it has been liked and it has likes, then go ahead and reverse that. But if it doesn't, then you should set it so that the state is updating it to be liked, and then update the like number. And then this down here is just rendering in that component that we're defining here with the little heart icon. It's defining the click method. So like when I click here, then it's going to call the toggle like function. And then in here it is rendering the amount of likes from the state. So when I click, it increments between 1 and 0. So that was really it for the hands-on portion. And once I'm able to figure out the API calls, this is something that I want people to be doing along with me as I'm live coding. I was just kind of running into some technical difficulties here. But I did have.
Could we do, like, let's assume that API call is failing.
Mm-hmm.
Could we do like a quick snippet that basically says instead of loading and like the catch, return, and error.
You got a microphone behind you?
That would work.
Yeah, sure. Here, can you repeat the question?
Sorry. So with the API not working, instead of it just saying like it's loading, would we be able to do like a quick component that just shows a friendly error message?
Okay.
Assuming that we are getting an error message.
Right.
Just to see how we would do that in React.
Yeah, totally. So what we've got here. So what I'll do is I'll just go ahead and break this URL here. So we can't return the data anymore. So now we're saying that since we can't return that data, then there will be no more API data in the state. And then that would be right here in the feed item. So instead of loading, we can say something like, oops, something went wrong. And it automatically adds another little guy there, so it kind of looks like a monkey. But you can do more advanced error handling based on like, okay, so the response didn't load yet, or it hasn't loaded yet, or it failed to load. Just some more fine-grained stuff like that. So since you guys have seen kind of a little bit of a hands-on example, I just wanted to kind of lay out some next steps. I know this was like a lot of information to throw at you. So here are some resources that I recommend that have really helped me out, or just that I've interacted with and I think are really good. So I would say the place to start, we've been going through a lot of like high-level concepts here. There's an idea in programming called abstraction. So that just means that you start out with simple things, and then you basically make them a little bit more complicated, but make them a little bit easier to work with. And that's totally what React is. But Free Code Camp is a really good way to understand exactly what's going on at a very base level. As you're going through Free Code Camp, a really good resource is MDN, which is the Mozilla Developer Network. It's very technical, but it's also very thorough. It's helped me out a lot. A couple of websites that I really like, Egghead.io and Front End Masters, both have really good courses for front-end web development, and especially React. I know both of them have some great React courses, some of them even taught by the people who have like helped create the software. And honestly, I am somebody who likes to read the documentation. So like, if you just Google React and go to the documentation, they have some great tutorials. And that goes for pretty much any technology or library that you're interacting with. You always need to document your work, and you can kind of, sometimes documentation can be a little harder or easier to understand and interact with, but it's always good to check it out. And I generally suggest these like in terms of kind of order you should go, getting kind of a base with Free Code Camp and MDN, expanding your knowledge a little bit with some courses, and then kind of diving deep into the implementations and the documentation. And one other thing that I really suggest is that you get involved in your local community. There's some really good things going on here in Columbus, like Columbus Web Group, Free Code Camp meetups. And if you're doing stuff kind of over the internet, there's a really good group called Reactiflux, which is a bunch of React devs. They're all in a Discord chat room, and they just talk to each other all the time. I also really like talking to other developers on Twitter. I don't do as much on Reddit, but I know that it's really active, and sometimes it's like really good for asking those more in-depth questions and like being able to kind of go back and reference it. And finally, I just urge you to keep in touch. Reach out to me, if you have any questions or want to talk about any of this. It's my Twitter, my personal website, and my email. And thank you for coming. I know we went over this really fast. You guys did a really good job of hanging in there. Any questions?
Yeah, just a question about how React and how you handled the API data.
Mm-hmm.
So I'm more familiar with Angular 2, but
Mm-hmm.
How did that data come in? How did it get to that nested component? Is the API call itself a component, or is it nested as part of the parent component, or just can you describe kind of how that fits in?
So let me show you again here kind of in the code, because I think it's easiest to kind of look at the code here. So the actual spot where the data is being called is right here from the top level component. We talked about those container and presentational components, where container components actually interact with data, and presentational components are just displaying data. So this app component is a container component. So what it's doing here is it's saying once this component mounts, so it is attached to this component, but then it's assigning a value to the API response that's calling a function that gets that value. So let's go down to call API. All this function is doing is returning a network request. Fetch is a way to grab data from the internet. The first part here is just saying, this is the URL, and fetch returns a promise, which is a little bit of a high-level concept, but basically it's a response You can say, okay, once I got that response, then take the response, turn it into JSON, which is like the objects we were talking about earlier, the keys and values between the curly braces. And if there's an error, then you would want to try and catch that error and log it.
And then how did it get to the child component? Is there some kind of binding or some kind of...
So once it is done calling that API, it's setting the state here.
It's all just right there.
So here, let me actually show you. In debug mode, this is one of the really cool things I was talking about in terms of developer tooling. So there's a really great tool for Chrome here. It's just a Chrome extension. And so what this is doing, this is going to look a little bit more like my code. So this is a tool that allows you to kind of see the components that are in your application here. So if I click on my app here, yeah. Oop, that's a little too much. So if I go here to this feed item, I can see that it is saying here that something went wrong. I don't know actually why. It's supposed to show you the state. So I can't exactly tell you why. Normally it has like the state, but the state is attached to a component. So like this app right here has a property called state. And it's just an object, and it can hold anything. And so the component state has this API data key in it that's holding this value. And then when I am rendering here, all the way down here, so this is still the same app component. And rendering is just saying, okay, once it's ready to put on the screen, do this. So I'm grabbing that API data from my state. This is just called destructuring. It's a way of accessing data in an object. And then I am passing that into the feed item as a prop. And the props are the read-only data points that just flow down through the components. And then this feed item here, when it's receiving a new prop, that API data is going to start out as null because we haven't completed the API request yet. But then once it's done, that prop will change. Once the component receives new props, then it's setting this item state to be that API data call. And then it's just rendering everything down here with that data. Anybody else?
Can you explain a little bit in more detail about how you handle data from props and how you handle data in state?
Okay. Yeah. So I think I've said a couple times the phrase like read only, and that's the big difference is that props are always passed down and they're read only. So a parent element can define a prop and then pass it down to a child. But a child can't redefine that prop. It's always going to be what the parent element says that prop is going to be. And that's a concept called like a declarative UI. You're saying, okay, it's going to be this value. I'm not telling you what the value is, but it's always going to be this value that the parent says it is. The state can be set internally by a component. So like a component can update its state whenever it wants. It can say, hey, I want to update my state, but it can't say, hey, I want to update my props.
And then how does React know when to like re-render something or like in the life cycle? How does it manage which one? I guess that's not a very good question. I guess can you explain more about the different parts of the life cycle?
Right. So there's actually a really great page here on the docs that I read all the time. And it lays it out in a really neat fashion here. So again, this is just the documentation on React. So this has a really concise explanation of the component lifecycle. So mounting is basically just saying, hey, I'm creating this component, so it goes through this. It was those constructor functions that we called, which is basically like as soon as this new element is called, you do this function. And then there's a component will mount. So this is called after it is like instantiated, but before it's actually rendered. Then you have the render, and then once that render happens, you can say, okay, it rendered, now I want to do something else. Then when the component is updated, you can, the component will know, oh, hey, I'm receiving a new prop once that data changes. So like if a parent sends a different piece of data down to a child, it'll know this is different. And it just does that by comparing the old value to the new value. And so if it's going to receive props, it can call this function before it receives the props. It can call this one once it's decided that it will update. There is, again, another re-render. And then if it did update, you can call this one here. And then there's just, once the component is like out of the web page, then it's just called component will unmount. So you can do any cleanup before, like if you had a timer that was attached to a component, you can stop that timer. Maybe one more question?
React or AngularJS?
I am very much a React man myself, but that's like kind of based in ignorance. I haven't done a ton of Angular, but I'm sure there are people who would love to fight about it. So let's get some fights started. But anyway, thanks for coming out and listening, guys. You were great. Sorry about the technical difficulties, but I hope you got something out of this.